When we generally think of automation today, we think of some combination of physical and information technology. However, automation can be purely physical or purely information-based and still be automation. At the advent of the Industrial Revolution, it was feared that automation would replace labor. These concerns are still present today in some industries. However, when we take a closer look at the research, we tend to find that automation augments rather than replaces labor. Let's see how. And so, we will be taking a look at the impact of automation on the labor market. Before we take a look at research that establishes that capital augments labor, let's first look at the more traditional view of this relationship, the solo growth model. Within this model, when there is an increase in capital investment, in this case, automation, this will increase labor productivity. In general economic theory, when labor is more productive, firms need fewer employees to achieve the same level of productivity. Thus, as productivity increases with automation, there is a reduction in the demand for labor, leading to less jobs. This, of course, is supposing that demand does not increase when we see an increase in productivity. Let's now look at the relationship between labor scarcity and automation. If automation within an industry is predisposed to being labor augmenting, that is, working with labor, then labor scarcity will inhibit automation due to an input being missing. If the automation occurring within an industry has a substantial relationship with labor, as in it does the same thing labor does, then labor scarcity will assist such automation due to the fact that it will encourage firms to fill in the gap with automation. However, Darren Asamoglu in 2010 found that cost savings needed to be significant before a firm will replace labor with capital in either instance. Let's now take a look at how cost dictates the pace of automation. Carl Ebel found in his 1986 study that the high price of automation technology acts as a barrier to entry for firms looking to reduce labor costs. He found that by the time the equipment had been depreciated out and used to its full extent, that the savings were very slim when compared to labor. These costs come in the form of custom machines built for specialized purposes. Those machines that can be purchased off the shelf, as it were, often need retooling for specific industries, and proprietary software machines are often developed as a supplement to these machines rather than purchasing ones available on the market. This research and development also represents significant cost to companies. Beyond the initial investment, capital has ongoing costs associated with it that can lead to higher costs than labor. Machines, such as this one, represent a significant investment. The maintenance itself can be time-consuming and costly. As a result, companies are hesitant to invest in such machinery, unless it can significantly boost productivity. Beyond the barrier to entry, Ebel found also a lack of correlation between the level of automation within a country and its level of unemployment. Japan, as a noteworthy example, had the highest level of automation at the time, but one of the lowest levels of unemployment. In addition to this, Timothy Doon and James Schmitz found that the number of production workers was more closely related to the relative price of the product being manufactured. The lower the price, the more workers were used in production, and vice versa. This meant that for the higher value items, there was a greater incentive for automation to be implemented, as its initial cost was offset by the higher value product. Furthermore, there was a greater level of non-production workers who were used in these firms, offsetting the reduced employment of production workers. With this division between production and non-production workers, we see the specialization of work. Since automation frequently reduces the number of tasks that one person must complete, they are able to hone a smaller set of skills with greater intensity. With automation doing the more monotonous tasks, they are freed to do the more complex parts of their job. Workers are able to be more productive in their work when they are able to focus in on those parts of their job that are more oriented towards critical thinking and skill rather than things like data entry or assembly line work that are easily automated. Bank tellers are a prime example of this. They were greatly helped by the advent of the ATM, as noted in David Autor's 2015 study. They spent less time counting cash and more time working with customers on a person-to-person level selling financial products, with the number of bank tellers actually increasing after the introduction of the ATM. However, what is a monotonous task? Well, when we study how people learn, we find that they have developed skills that they have never consciously trained. This is best stated by Polanyi's paradox, which is as follows, quote, "We know more than we can tell." What this means is that we pick up skills that are tacitly learned by doing them rather than studying them. These tacit skills are divided between manual skills, which are judgments regarding decisions based in tacit physical intelligence, and abstract skills, which are judgments regarding decisions based in mental or emotional intelligence. An example of a tacit physical skill is knowing when to apply the brakes on a moving forklift. An example of a tacit mental skill is being able to improvise on the spot, otherwise known as divergent thinking. Machines, generally, aren't very good at divergent thinking. Generally, they're good at whatever task they were programmed to do, such as adding numbers, or, in this case, lifting pallets. Due to how difficult it is to program skills that are learned by doing, they are, for now, out of the reach of automation. The general observed effect of automation on the labor market is not widespread unemployment as previously thought. It is job polarization. And it is this greater emphasis on abstract skills like critical and divergent thinking that lead to job polarization. Current concerns of automation supplanting labor and reigning supreme are still generally far-fetched. Contemporary research can point towards specific industries and tasks that have been automated, such as elevator operation and horse-drawn carriage driving, but widespread unemployment has yet to be observed. Much more concerning is the job polarization that occurs as a result of automation. Middle skill and wage workers, otherwise known as the middle class, are hit hardest by automation due to the more basic elements of their jobs either being fully automated or delegated to a lower wage job, and the more complex parts of their job being delegated to a higher wage job. This cuts them out. Nearly every study reviewed for this study had a mention of such polarization of the elimination of jobs in the middle of a company and an increase at either end. To address how the labor market is affected by such technology, further study into how the quality of life changes as a result of such job polarization may want to be studied. The changes wrought by automation will not be as cut and dry as either side of the issue, be it Luddite or technocrat, wants it to be.